Hello everyone, welcome to a brand new season of Dave Does Math from Home. This is not just a brand new episode, we're kicking off a whole new season. It is January 2021 and we are doing videos for MA 120. This is College Algebra and Trig is the official name. I'm probably just going to call it Algebra pretty much forever. The Trig is minimal at the end. Mostly it's Trig. We're kicking off this season with our very first section. We're going to do section P1. I forgot the actual name of the section P1, but it is about expressions, so I'm just going to call this expression basics. There's three important things we need to talk about in terms of expressions. We're going to talk about substituting values. We're going to talk about simplifying things, and we're going to talk about order of operations. And hopefully this is all going to be a review for you. But we're going to go through it all anyway, so that everyone has a real good idea of where we're starting from, and then we can move from there. So we're going to start with substituting things. If you have, I guess no, let's start with what an expression means. Expression is anything that doesn't have an equal sign. If something has an equal sign, if you're dealing with like 2x plus 3 equals 7, this is not an expression. This is an equation because it has an equal sign in it. And when you have these equations, there's a lot of stuff you can do with them. Basically, when you have an equation, you can do anything you want to the equation as long as you do it to both sides of the equation. So as long as you keep it balanced, you can do anything. You could square both sides if you like. Doesn't matter. You can do anything you want. That's not what we're dealing with yet. We are not doing equations. We're doing expressions, so that's just the 2x plus 3 bit. This is an expression, doesn't have an equal sign. This is an expression, doesn't have an equal sign. 6 times the quantity 4x minus 7 plus 3x minus 12. This is an expression. All of these things are expressions because none of them have equal signs. That's the big distinction we're going to make between expressions and equations. When you have an expression like this, if it's not an equation, like I said, equations you can do anything you want to. If you have an expression, the things you can do to the expression are much more limited. You can simplify them, like this bottom one can be simplified. This one can't really be simplified. It's just a 7. This can't be simplified. The x and the 3 are not like terms, so you cannot combine them. So these are already simplified. This bottom one could be simplified a bit if we wanted to, or we could evaluate them given a certain value of x, or y, or t, or f, or whatever variable letter thing you have. So that evaluating expressions is what we're going to start with. Let's say we have if x is, let's start with 4. If x is 4, then 2x plus 3 would be 2 times 4 plus 3, and that'll give you 11. If x is 4, 7 is still just 7. There's no x's in this, so it doesn't change if x is 4. It doesn't matter what x is. 7 is always going to be still 7. And this one on the bottom is going to be kind of a mess, but we can do it. This is going to be 6. Now, let me just rewrite the whole thing. 6 times 4x minus 7 plus 3x minus 12. Okay. If this is our equation and I'm plugging in x equals 4, sorry. If this is our expression, I'm already getting it wrong. If this is our expression and I'm plugging in x equals 4, then we're going to get 6 times 4 times 4 minus 7 plus 3 times 4 minus 12. So this will be 12, and this will be positive 12, that's negative 12, those things cancel. This will be, I'm going to do the inside parentheses first. This is 16 minus 7 is 9. 9 times 6 should be 54. So That is how we're going to evaluate expressions. Sometimes you might have to plug in more than one variable at once, like if something gives you an x and a y, plug the correct values into the correct letters. That's about it for evaluate. Where's my eraser? That's about it for evaluating these guys. So I propose we start talking about whatever I said was next. Simplifying them. Yes. And I just erased the thing I wanted to simplify. Okay. Let's see if I remember it. 6 times 4x minus 7 plus 3x minus 12. That's one of the things I wanted to simplify. If you have an expression like this, and you're not given an x value, simplifying is about the only thing you can do to it. And so simplifying, there's only a couple main parts of simplifying. We're going to distribute multiplication into parentheses. When you have multiplication times addition or subtraction in parentheses, you can distribute that. So that'll be 24x minus 42 plus 3x minus 12. And then you can combine like terms. So the 24x and the 3x are like terms because they both have exactly one x in them. So that'll be 27x. The negative 42, the negative 12 are like terms. That'll be negative 54. And that's about all there is to it. So distribute combine like terms. I'm stepping on things. That is pretty much the whole part of simplifying. Can we make up something that is more interesting to simplify than this? Let's do 2 times, let's do a big bracket here. We'll do 8 minus y plus 2 minus 3 y minus 10. I'm just making all of these up, so we'll see whether or not this is more or less interesting. In this case, when you have like nested parentheses like this, you should work from the inside out. I remember what I wanted to say about this one. When you're combining like terms, make sure that you keep track of what's positive and what's negative. Like, honestly, I think it's much, much better. Instead of thinking about this as subtracting 42, I think it's always more convenient for me to think about this as being a negative 42 and this as being a negative 12 and everything. If this isn't nice for you, then don't do it. But the way I think about all of these is I pretend all the subtracted terms are actually just negative terms, and that makes it easier for me to parse where the signs go. So back to this one. I'm going to work from the inside out in this big set of parentheses here. I have a negative and then this y minus 2 piece. This counts as a distribution situation. So we have to distribute this negative sign to the y and the 2. So that will leave us with 2 times 8 minus y minus 2 minus, I'm going to distribute the negative 3 to these guys. So this will be negative 3y plus 30. So that's the other really important thing to keep in mind. when you're adding and subtracting negatives, keep track of what their signs should be and how they combine. If you are distributing with negatives involved, make sure that you distribute the negative piece as well. So now I can combine some like terms inside of this. I have a positive 8 and a negative 2 here. So I'm going to call this 2 times positive 8, negative 2 is 6. 6 minus y minus 3y plus 30. This part hasn't changed. So then this will be, I can distribute the 2 now. So this is going to be 12 minus 2y minus 3y plus 30. And I think in the end, after I combine all these guys, I'm going to have a negative 5y and a 42. Hopefully the glare is not too bad. You guys will have to let me know in the comments if the glare on this whiteboard is terrible or not. This is my first time recording a math video in this room, and I could do something about the glare if it's a problem. I'm just not sure how bad it's going to be in the video. Let me know. So that's about all I wanted to say in terms of simplifying things. There's only 2 real steps. There's some trickiness associated with some of the steps depending on what you're working with, but it's the kind of trickiness that me over explaining I don't think is going to help very much. It's the kind of trickiness that you just practicing it a lot is what's going to help. So fortunately, there's lots of homework problems for you to practice on in section P1. So it's not going to be a problem. Let's erase all this, and then we can talk about whatever the third thing I said was. Order of operations. Let's talk about order of operations. Okay. Order of operations is weird because people like to go on Facebook and post these messages that say like 90% of people get this wrong. And it's just a math thing, like 2 plus 6 divided by 3 minus 12 plus. Now let's do times 12 minus 4. Just a bunch of weird nonsense like this. And the thing that's really frustrating about this is that the reason that this gets so much traction on Facebook is because every time they do this, it's sort of like deliberately written to be ambiguous and sort of confusing. And there is one correct answer, but it's not. It's a correct answer because it's what mathematicians have decided is the best way to parse expressions like this. There's no like objective mathematical force that is working in the universe to make sure that this is a certain value. It's just how mathematicians chose that all this should be handled. So if we're doing order of operations, we're going to start with parentheses. If you have multiple sets of parentheses, start with the inside parentheses and then work your way out. So in that case, that's going to be these guys. Oh, I should do some exponents in here as well, huh? Now I have an exponent in here. Okay, good. So we're going to start with parentheses. That's this. 12 minus 4 is 8. So 2 plus 6 divided by 3 squared times 8. The next thing we do in order of operations is exponents, which is why I wanted to put an exponent in here. So the exponent will transform this 3 squared into a 9. And then some of you may be thinking about there's an acronym, PEMDAS. The next thing we do is the M and the D, which is multiplication, which I can spell correctly if I try hard and believe in myself. Multiplication and division. And I put them in the same line because these, like if you're just thinking about the acronym, PEMDAS, PEMDAS, that makes it sound like multiplication always comes first, before division, and it doesn't. Multiplication and division are on the same level, and if you have both of those expressions, or both of those symbols in the same expression, you go from right to left. So even though multiplication comes before division in the acronym, they're secretly the same thing, and this division symbol happens first. So we're going to do this division, then we're going to do this multiplication. So 6 divided by 9 should be something like 2/3. 6 ninths simplifies to 2/3 times 8. So that's us doing this division first. And now we still have some multiplication, so we're going to do this piece next. So 2 plus, this will be 16/3. We treat this as an 8/1. We'll just multiply straight across. Hopefully everyone remembers what to do with fractions. And then we can add these things. So this 2, addition, subtraction. There's no subtraction here, so I don't have to worry about that. There's only one thing left, it's the addition. To add these things, I'm going to turn this into a 6/3 plus 16/3. I'm going to end up with 22/3 is my final answer here. So we have this PEMDAS thing, parentheses, exponents, multiplication, division, addition, subtraction, and the thing to keep in mind about this is that multiplication and division are essentially sort of the same operation. In the same way that I said a couple minutes ago that instead of subtracting numbers, think about adding the negative version of the numbers. Addition and subtraction are secretly the same thing, just with negative numbers. Multiplication and division are secretly the same thing, just with fractions. Like instead of this being divided by 9, you could very easily think about this as being times 1/9. That's what division means. So these are secretly the same thing, and they are on the same tier, sort of the same level. And that's the order. And now you will never again be caught off guard by weird, obnoxious Facebook posts claiming that people are going to get the order of operations wrong. This is how we have collectively decided that we should interpret these statements, and this is what you get when you simplify all of that. So there's plenty of opportunities for us to practice substituting stuff on the P1 homework and simplifying stuff on the P1 homework, and there's a couple pretty interesting order of operations problems on there as well. So give those a shot, and I will, if you have any trouble, come find me in the ASC or come talk to me in class. Good luck.